Good morning, everybody. It's great to be here and see so many familiar faces. It's a pleasure, and it's my pleasure also to introduce Walt Halipchuk from Copper Mountain. So we're here to present you a remarkable project, a journey of about 2.5 years. That's a sure path to electrify mining haulage. This project comes to you from British Columbia, Canada. From British Columbia, Canada. On our license plates, we say beautiful British Columbia, not only because we have beautiful nature and scenery, but we also have rich deposits in copper, gold, zinc, moly, coal. And we're also proud to have the only operating trolley assist system in a real mining environment. So at ABB, our mining team is proud to take active part in the mining industry towards sustainable mining. And we counted our success when our customers achieve successes in reducing their GHG gas emissions and also in achieve sustainable mining. So we're very grateful to be one of the partners with Copper Mountain through the journey from a feasibility study in early 2020 to having the trolley assist system run just about over a year now. We'll present here a brief video for you just to kind of give you a brief overview of the project, and then Walt will take us through the journey, how they actually took the project from very initial concept stage to an operating trolley system.
Yeah. George, if I just could, though, I know everybody's maybe been sitting here for a large part of the audience, and I have a little exercise first that I would like to do just before the video. So if it's just everybody who's in the seats, I know you've been maybe sitting there for about 2 hours now. Can you just stand up and just stand up for a second there? That's great. Let's stretch out. And now let's put your arms up like this. No, just straight. That's pantograph up, arms down, pantograph down, trolley up, trolley down. Okay, let's go.
I'm sure you're all thankful for this.
So yeah, welcome everybody. And this is going to be a practical discussion of a trolley fleet in service this morning, 7 trucks operating, full productivity here. So what about this company that put this together? Copper Mountain Mining Corporation believes we're powering a sustainable future. We're looking to advance the green energy transformation by tripling our sustainable copper production within 5 years. And the 4 pillars of our company are founded on operational excellence, growth, environmental and community stewardship, and team excellence. And the values that enabled this company to achieve this here, these are our 8 values that you'll see posted within my presentation here. First is safety. Everybody goes home safely every day at the end of every shift. And that also holds true when you introduce new technology, and that is our goal. We act with integrity. We are open with what we're doing and collaborate. We challenge each other for the good of the team. Innovation is critical. This project wouldn't help this project wouldn't happen without this pillar of innovation. We're quick, we're nimble, and we're flexible, and you'll see that demonstrated through this presentation. And empower. We give people the authority and the rights to make decisions and make a change, and with that, we continue to invest in our people at the mine site. So Copper Mountain Mine, the Trolley Assist project is possible. The focus was GHG reductions here, and haulage is the biggest source of GHG emissions at site. We have some 110,000 tons of GHG emissions, and we're on a journey to reduce that to become one of the world's cleanest open pit copper mines. So with the BC Ministry of Environment and Clean BC and the Climate Action Secretariat and some key partners, we put this vision into development, I would say. We were fortunate enough in British Columbia, we have opportunity to secure some funding through Clean BC, where we bid in for dollars per emissions reduced. So it's a competitive process, and we, from the carbon taxes that we pay for the fuel we purchase, it goes into a pool, and from that pool, projects have the opportunity to bid in and receive some funding to help them with the capital costs on these projects. So, a bold vision for change. Inspired minds can change minds. And really, hearing some of the speakers this morning already, it truly is a partnership to make something like this happen. And so with these partners, we were able to move forward. So everybody, I think, understands the how of a trolley truck, I guess, or you wouldn't be here today. The key is that the wheel motors have 2,600 horsepower available. That's not being utilized. I'm sorry, the diesel engine, of course, is 2,600 horsepower. You've got 2.8 meg of power in the wheel motors. So coupling the motor to the wheel motors to the trolley line, you utilize that available energy that's there. So the why are the CO2 reductions, the NOx, diesel particulate matter, the productivity improvements, the speed is doubled, reduced fuel burn, which leads to increased diesel engine life, and significant noise reductions. And so the trolley economics are highly sensitive to fuel prices and less so to electricity costs, especially in British Columbia, where we have a tariff for power. So the results are it takes about an average of 113 kilowatts to pull a truck loaded up to 10% grade, and 0.9 liters of diesel to maintain the emergency steering functions and brake functions of the truck, compared to between 30 and 35 liters of diesel under conventional haul. So when we started this project, our target emission intensity reductions were 7.2 kilograms for the trolley trip. That's what our focus was. What we've been able to verify is 3.5 kilograms of CO2 per each trip. So the trolley project has truly exceeded the expectations from a GHG reduction of what we set out by 100%. So what does this mean? It relates to approximately 7,000 tons of GHG reduced just from the initial 900-meter trolley run, okay? It's pretty significant, 140,000 tons over the project life, and this is all determined on your mine plan. For us, Copper Mountain utilizes somewhere around 600 gigawatts of electricity a year. The trolley project will only consume 12 gigawatts of that 600 gigs of power that we utilize. So I think many people maybe have seen this. I call this the Great Drag Race. And this was upon commissioning when we received the ministry approval to operate the first truck in British Columbia on the trolley line. And this video will show haul truck 30 climbing up at about 23 kilometers an hour here. and passing one of the other haul trucks, diesel-fired truck, in a center lane. So we have 3 lanes, and I'll talk a bit about that in a second. Halfway, we're at the halfway point here, where the ABB DC substation is and the feeder cables connecting to the overhead catenary system. So the diesel truck will continue, and as I said, basically twice as fast, of course, as the trolley truck is twice as fast as the diesel truck. Pretty impressive. So, as I said, speeds achieved of 24 kilometers loaded with 220 tons payload, 42 kilometers on empty, and the fantastic emission reductions, 112 kilowatts of power in British Columbia, factoring in demand charges. It's about $7.40 a trip versus the diesel cost of about $60 Canadian. So 4% emission reductions, and so about 13% of the energy cost here. So the project was, had received the TSM award for the Environmental Excellence Award in Canada for our execution of the project. And that's the key project team that we put together to put this in place. So our vision at Copper Mountain, this is our journey towards our carbon intensity reduction. It's a combination, of course. In the numerator, you have the tons of CO2 you're producing. In the denominator, your copper production, copper equivalent production. So trolley assist phase 1 is in place. We're further electrifying. We have another PC8000 coming, which will make three electric PC8000s at the site. We have another of our partners here, Epiroc. We have a total of 4 Epiroc electric drills at site as well, Pit Viper 351s. And we continue to increase our production at the site. We also have a renewable diesel test just finalizing here with Cummins on the QSK 60 engines. So one of the trucks that you see here today is really, I call it the world's cleanest haul truck. It's a trolley truck running on renewable diesel, haul truck 35 as well. That was so easy. Not really. So this is the practical part, and I hope during the conference, this is what it's about, putting something into reality here, I'll say. So thermal line upgrades. So we're serviced by, currently, we had to get to 100 megs of power from 65 megs. So we work with the utility to do what was necessary to do that. It takes about 38 months to do that. We had to build a new substation in our case. Every mine might not have to. We needed a substation. We utilize it for other aspects of the mine. We needed to, we have some water pumping as dewatering continues to become a more significant issue at mine sites. So we had to upgrade a substation that was originally there in 1974. So I took that on under the project. We constructed 5 kilometers of 25 kV double circuit line from that new substation to the Trolley DC substation. And then with our partners, ABB, they delivered the E-room, modular E-room, complete with the 2 6-megawatt resi block rectifier transformers, and supplied the overhead catenary system. Mine haul road prep and widening, the Komatsu 835 240 trucks supplied through SMS equipment. And of course, the great support of the BC Ministry of Mines and helping us and guiding us through the review process to make sure that the project was going to be implemented safely and there was no risk to the workforce. So upgrading, thermal upgrades on a line to get us to 100 megs. So that required 4.5 kilometers of new conductor at the site, as well as supply of the new substation that we built ourselves. We built this substation within 12 months, 63 MVA, 138 to 25 kV substation, complete with 2 by 10 megavars of StatComs supplied through Synergy Engineering and Inga team. We have this double circuit, 45 MVA transmission line we built, and this is kind of the terrain we're talking about, quite some of the steepest river canyons through the Similkameen River here running through our site, our property, and we built this power line in about 6 months. So the ABB trolley substation, George, do you want to talk about that?
I'll pitch in. So the trolley, the power supply to the trolley has two main components. The DC substation that converts the AC coming from the 25 kV line to DC to power the trucks. And then, of course, the OCS, or the overhead catenary system. So our supply included the DC substation as well as component on the OCS. Copper Mountain took over the construction to our design. And if you go to the next slide. So inside the substation, your typical AC switchgear, DC rectifiers, DC switchgear, and then, of course, the rectifier transformers outside. This is kind of what we call the DC substation. And, of course, there's a control system that monitors the performance of the electrical power supply. And there's also instrumentation that are mounted in the OCS to monitor things like the load height, when they're struck or not, and also light indications to tell the drivers it's okay to approach the line or not. So there's a red-green light traffic system in there. On the OCS, you can see some of the instrumentation. There's also current sensing that need to be monitored to make sure we do not exceed the capacity of the line. So all of it comes together as an integrated system to work with the rest of the trolley assist to supply the trucks.
As I would say here, so this is a three-lane haul road, 56 meters wide. So this road services our primary crusher, so it's an ore haul. So our crusher feed required is 60,000 tons per day, and the trolley fleet is supplying the ore to the crusher. So 7 trucks, 60,000 tons per day. Who's good with the calculator? 220 tons payload. That's over 240 trips a day, something like that, that we're making up there for the feed for the crusher. So to build it, there was a series of switchbacks you can vaguely see in the photo, especially to the right of the screen. There was 3 switchbacks that previously went up to the crusher. So we moved 4.25 million tons of material. Mining costs somewhere less than $2 a ton. But some of that, of course, was ore as well as we mined that, and we developed that ramp. With the help, this was the original design of BBA Engineering that helped us with the ramp design. So fairly tight to the cross arms, and that's the way we like it. We don't want to spend more money on developing costs to extend the cross arms. We don't think that's required. There's no problem maintaining a lateral position of the truck along the line with that gap. So I wouldn't waste the money in putting cross arms out further. The Komatsu truck, has been great. We were looking for fleet additions, and this all started in 2018. We went for a competitive process. We decided on the Komatsu 830E 5T for us. Would be the right fit. So with that, we purchased 11 trucks capable. We've currently converted 7 of them, and we have a payload normally of about 220 metric tons. We have weigh scales on the side of the trucks that we use for loading. With trolley, we use about 216-ton payload. We derate about 4 tons for the trolley infrastructure that you see in this slide. The pantograph assembly, we currently have an electric design assembly of the pantograph. There's the trolley switchgear and the control cabinet. So it's been, we've also added a deflector on the canopy to stop ore from hitting the pantograph structure to help reduce the risk of damage. So the final slide is in terms about our review process, commissioning, and operational readiness. This is a big aspect of any project. Many in the room have put in autonomous systems, so there's also a change management here. We worked with the BC Energy and Mines, and we established an advisory committee to review all the documentation on the project and develop our safe work protocols. Excuse me. We conducted a review and issued a risk assessment and with the operational team at the site that was going to be responsible for operating and maintaining the assets. We received conditional approval from the ministry on March 31st, and we continue to advance towards operational readiness. And we are working on developing the project management plan that will be used to evaluate this project and other similar projects in the future. So the key learnings, to take away from this of course is, electrical supply. Our site is constrained. Other sites may not, but we have only a 138 kV line. I'm currently doing a study for 131 megawatt supply to the site, but after that, the next stage would have to go to 256 kV, and that's going to be a big job. The truck was the first of its kind, so we worked through the design improvements and getting the electric pantographs right. We pushed Komatsu to get this fleet in production as quickly as possible. Being a smaller mining company, we didn't have the ability just to play around and put 1 or 2 trucks in production. We needed these to be working assets that could have 86% availability, and that's what they deliver. We have specialized skills and craft training required on a lot of aspects of the project, so we work to train our workforce and hire contractors where we needed. Mine planning and sequencing challenges. Currently working on another feasibility for our 5 to 15 year mine plan and determining where those next phases of Trolley are going to fit in that 5 to 15 year mine plan. So we're currently evaluating a 2.3 kilometer haul back to connect to the existing line, as well as another waste run. Road surface is critical. For the road surface to be graded, we invested in a Cat 16M GPS controlled grader to maintain the elevations of the road, which is critical, as we have minimal working range there on the truck, less than about 2 feet, I guess, once you have a full load on there. Maximize the mine plan, tonnage for tonnage hauled, and grade are critical. Data collection, we're working on that. You need a strong plan to capture the truck PLM data and the system metering data, because this is an operating fleet. We have to prove to the world that this project is truly a success. So capturing that data is a key step in that. Rock damage. Continue to work with the shovel operators to make sure that, when you're swinging the load over, what happens, so when you're swinging, you're loading, if the operator doesn't stop and release the load into the center of the bucket, if he continues swinging and releases, you can get rock damage. That could happen. COVID was difficult. This was a COVID project, so many of us in the room have probably conducted continued our operations and done projects during COVID, which was more complex. We had a catastrophic flood in the community of Princeton as well, so we had to stand down for 5 months as we let the emergency relief workers in the community and get the community back on its feet. Payload reductions of about 6 tons, but makes up with it on twice the speed. Power management system, excuse my throat here, low load factor and high demand factor trolley is right. You'll see 2.8 megs, so with 3 to 4 trucks, you're pulling somewhere between 9 and 11 kVA of demand, but it's 2.5 minutes that you're on there, so it's more of a demand project than a energy project, let's say. We've had some issues with the pantographs that we have a resolution for right now that we're working to. Brush life wear as well. Center contacts, we're running down a straight line on the trolley. We have 3 sets of brushes on each pantograph. We're seeing a lot of wear down the center line of the one brush, so we're working on that as well. I'm going to take you for a ride in the truck. There's lots to watch in this slide. So you can see the RPM here. We're idling, 750, we boot up, start to climb the ramp here. You can see the fuel gauge there at reading at 450 liters an hour that we're burning, 1800 RPM in the truck. We're coming up, get the signal for up pantograph. The operator will raise the pantographs on the truck, You'll watch the RPMs will cut down immediately once we have contact here. The RPM will direct. Watch the speed build on the truck. And we'll continue. You can see the position of the truck on the ramp on the right top corner.
Noise in the cab as well as significant.
This truck was a little bit light loaded for some reason. It's about 202 tons. You can see that in the corner. Density of the rock or whatever at that point. We added these tires on the berms on the right-hand side for some protection to our pole structure, as well as the medium lane to differentiate between the diesel haul traffic and the electric trolley truck. Coming up to halfway point, you'll see a green light from the DC substation, which means that there is no more than 2 trucks. We continue up the pantograph here with this, up the ramp with this truck. We had no loss in power as we crossed over the second section. We have a diesel truck in our sights on the left there, and it's a race to the crusher pocket right now. We added these flags on the right-hand side on the cross arm, just for a old-fashioned tick on the mirror if the operator ever swayed away. There's an onboard guidance system, electric guidance system in the truck. It's just another little additional safety measure that we added. They're not really required. It's more of a comfort thing. But you can see the road surface with that grader does a good job maintaining the road surface. And that's key. You know, there was some comments in terms of what Barrick did early on in the 80s with the system not working, but road surface preparation is critical. We've had some soft spots, but nothing really significant. You dig the soft spots out like any good miner would do on any haul road, fill in the material, and then get the correct elevation. You wouldn't have a problem. But I hope this it excites you in the room here, and it shows you what's really possible. So 7 trucks running today, delivering 60,000 tons of feed to our primary crusher.
Okay, thank you, Walt. So just a few words to wrap it up here. The Trolley Assist project, I'm sure now you have seen the 7 fronts the projects went through. Is not just a simple piece of equipment that you can buy and install. It really has to be woven into the fabric of the mine plan. You have a lot of consideration to think about. At ABB, we consider it a very important piece to complete the electric mine puzzle or electrify the haulage. Whether it's today with the diesel electric trucks or in the future when we have battery electric trucks, you're going still to need a lot of power going up those ramps. So we consider it a very important piece until the full battery electric truck become commercially viable, and even when they do, you're still going to need some form of trolley. So in addition to the consideration presented here, I also like to say that we are very hard at work to make this trolley assist a more robust solutions with improvements that include things like relocatable infrastructure. Today, relocating the infrastructure is a very costly exercise, and mine haul roads change frequently. So we have some design in the works that will allow us to improve the timing required and the cost required to move the infrastructure. We're also investing in the charging of battery. When we have battery electric haul trucks, we need to charge them when they're under trolley, not just go up the ramps. So we're working on that aspect as well, and you'll see a lot of the other vendors that are providing pantographs are also working on the same to allow more power to be absorbed on the truck. Also, one important aspect that's in the consideration right now is how do we integrate trolley with autonomous haulage. Eventually, autonomous will become quite prominent in the industry, and there's a lot of work that needs to be done in that aspect, as well as the automation and getting the data from the trucks into a central system that allows you to actually monitor and forecast when you need to charge, how much power you need, and build that into your mine plan. So just to say thank you for your presence and attention. I hope you enjoy the rest of the conference. Thank you, Walt.